So far with rational functions, we've talked about how do we find their domain, we've talked about how do we simplify them, and we've also talked about how do we multiply and divide them. So the last thing, well, I guess the second to last thing we're going to talk about is how do we add and subtract with rational expressions. It's going to be very similar to what we do with a fraction that does not involve polynomials. So we're still, if you think about if I were adding two fractions, I would have to get a common denominator, add or subtract straight across the top, and then keep the common denominator. I'm still going to do that. However, in order to find the least common denominator, it is going to be much easier if I factor first. So I'm going to start by factoring, then I will find my least common denominators. I'll be sure and rewrite both expressions to have this common denominator, because once I have the common denominator, I can add or subtract across the top, and I can keep the same denominator. One thing I need to be careful of is when I'm subtracting, that I actually distribute that subtract sign into the entire second function, and I'll show you more what I mean when we get to a subtract problem. There are 3 examples on this video. 1 and 2 being add and subtract, and then number 3 being very similar to number 2. If you feel like you really got it on number 2, feel free to try number 3 on your own, or to skip number 3 if you, like I said, really have a firm grasp of it. So looking at example 1, according to my steps here, the first thing I'm going to do is factor. I should point out that you really only need to factor the denominator on these types of problems, because we are going to expand and try to combine like terms on numerators anyway, so there's really no point to trying to factor the numerators. So looking at example 1, I go to factor my denominator, and I know I always run out of room, so I'm going to kind of put it up here. I'm going to look for factors of negative 12 with a sum of negative 4. Because I have a trinomial that has a coefficient of 1 on my quadratic x squared term. Well, I know that negative 6 times positive 2 is negative 12, and negative 6 plus 2 is negative 4. So that is going to factor to be x minus 6 and x plus 2. Plus sign drops down. Looking at my second fraction, I notice that I have a GCF of 4 on the bottom, so I'll take that out. So next thing I'm going to do is I'm going to find my least common denominator. I'm going to do that by taking every single factor that occurs in my denominators. So I see an x minus 6 occurs. I see an x plus 2 occurs. And when I grab this x plus 2, it automatically grabs this x plus 2 as well. And then I also have left a 4. So my least common denominator will be x minus 6 times x plus 2 times 4. So I'm going to look at my left fraction and ask myself, what do I have to multiply both top and bottom by in order to get that least common denominator? Well, I'm going to have to multiply top and bottom by 4. When I look at my right fraction, I'm going to have to multiply top and bottom by x minus 6. Once I do this, my problem now becomes 4 over, and since it doesn't matter where this 4 goes, since it's multiplying, I'm going to go ahead and put it in front. 4 times x minus 6 times x plus 2. The plus sign in the middle drops down. 3 times x minus 6, and I am going to go ahead and distribute that 3x in. So 3x times x is 3x squared. 3x times minus 6 is minus 18x. All over 4 times x plus 2 times x minus 6. Well, looking up at my steps here, now that I found my least common denominator and rewrote both expressions to have the common denominator, I'm just going to add or subtract across the top and keep the same denominator, giving me a final answer of 4 plus 3x squared minus 18x all over 4 times x minus 6 times x plus 2. And I do not need to expand the denominator, only the numerator. The reason I want to expand the numerator is because there is always going to be a potential that when I put these together as one fraction, I will have some like terms I can combine, but I won't know that unless I actually do the expanding. Since I'm keeping the same bottom, I don't have to worry about having like terms, therefore I don't have to worry about expanding it. So this will be my final answer. Looking at example 2. First thing I'm going to do in example 2 is I'm going to go ahead and factor. I'm going to go ahead and leave the 2x. And when I look here, I notice I have a trinomial with a coefficient of 1 on my quadratic term. So I am going to look for two things that multiply to give you negative 3 and add to be negative 2. Well, how about negative 3 times 1 and negative 3 plus 1? It looks like that works. So I'm going to have 2x over x minus 3 and x plus 1. minus, remember I already talked about how we do not need to factor the numerator, so even though there's a GCF of x, I'm going to go ahead and leave it. I see that my denominator here is already in factored form, which is kind of nice. So now the next thing I'm going to do is I'm going to ask myself, what is my least common denominator? Well, remember, in order to find it, I'm going to grab all my common factors, or my factors from all of my denominators. So I'm going to grab an x minus 3. I'm going to grab an x plus 1. It also counts for this x plus 1. And then I'll grab that 4. And now from here I'm going to ask myself, what do I have to multiply each fraction by in order to obtain that common denominator? Well, here on the left I'm going to have to multiply by 4. Here on the right I'm going to have to multiply by x minus 3. And just like before, I'm going to go ahead and do that. And I'm going to go ahead and expand it on top, and on the bottom I'm just going to leave it in factored form. So on top I get 8x. The bottom I'm going to put the 4 in front because I like to have my numbers in front, but it really doesn't matter. Minus, I noticed that even though this wasn't grouped together originally with parentheses, I know that because it started off together in one fraction, it does need to be grouped together, and I do need to FOIL. So going ahead and doing that and FOILing, I get 3x cubed minus 9x squared minus 5x squared plus 15x. And then I'm going to leave my denominator in its factored form. So now here's where I said you have to be really careful with subtracting. With subtracting, I have to recognize that I am subtracting this entire piece, not just the 3x cubed. This whole function is being subtracted. So here's what I'm going to do. I'm going to go ahead and say that minus 9x squared and minus 5x squared is minus 14x squared. And then I'm going to distribute that minus into everything when I combine my two rational functions with the common denominator. And that's going to give me 8x minus 3x cubed. Remember, I combined these to get minus 14x squared, so when I distribute the minus I get plus 14x squared. And then plus 15x all over 4 times x minus 3 times x plus 1. So now from here the only thing I have left to do is ask myself if there's anything that can be combined in the numerator, and I see that 8x and 15x can be combined. So I'm going to say I have a final answer of negative 3x cubed plus 14x squared plus 23x all over 4 times x minus 3 times x plus 1. And like I said, that is my final answer. So from here I want to move on to the third example. So this is a good one for you to try, or if you've really got it, like I said, you don't necessarily have to watch this. It will be really similar to the second one, but if you want to make sure that you really got it, go ahead and try it so then you can see how I do it after you're done trying it. So first thing I'm going to do is I'm going to go ahead and factor my denominator again. So again, I see I can use a factor sum table, so I'm going to do factors of 4 with a sum of 4. And I'm going to go ahead and say that's 2 times 2 and 2 plus 2. Nice and easy. So I'm going to get x plus 2 times x plus 2 minus 2 times x minus 3. And if I wanted to, I really could have, and I am actually going to. Because I'm going to anticipate that I'm going to have to multiply that out anyway, I'm just going to do it here and say that I have 2x minus 6 on top. All over, I notice that this is perfect square minus perfect square. So my a that's being factored to give me x squared is x. My b that's being squared to give me 4 is 2, and I get x plus 2, x minus 2. And now from here I'm going to ask myself, what is my least common denominator? So in order to have my least common denominator, I grab everything. I'm going to grab an x plus 2, and remember when I grab it for one, it counts for the other one. Because this still has another x plus 2, I have to write another x plus 2. And then I'm also going to have to write that x minus 2, and I can't put it all in one line. So then I'm going to say I'm going to have to multiply top and bottom here by x minus 2 because it does not have the x minus 2 yet. And I'm going to have to multiply top and bottom here by an additional x plus 2 because it does not have the x plus 2 yet. So I'm going to go ahead and do some FOILing on top and leave my denominators. So on top I'll get 4x squared minus 8x minus x plus 2 all over x plus 2, x plus 2, x minus 2 minus, foiling again, I get 2x squared plus 4x minus 6x minus 12 all over x plus 2, x minus 2, x plus 2. Before I combine them and put them as one fraction, I'm going to go ahead and clean up my numerators a little bit because I see that in both of these I can combine some like terms, giving me 4x squared minus 9x plus 2 minus 2x squared minus 2x minus 12 And so now I'm going to go ahead and I am going to combine my two fractions since they now have a common denominator. I do have to make sure that this subtract sign gets distributed to all these terms. So I'm going to add some parentheses here to remind myself of that. And then I'm going to have 4x squared minus 9x plus 2 minus 2x squared plus 2x plus 12 all over x plus 2, x plus 2, x minus 2. And for my final step, I will go ahead and combine like terms. So 4x squared and minus 2x squared is 2x squared. Negative 9x and positive 2x is negative 7x. Positive 2 and positive 12 is positive 14. All over, again, that same common denominator. And that is how you add and subtract with rational functions. It can be a very long and tedious process, especially if your least common denominator starts including more and more factors. So.